Hello everyone, welcome to Fun with Learning. Today we'll learn how to solve integrand containing rational function. We define rational function as a function which can be written in the form of numerator and denominator, where both numerator and denominator are polynomial, that is px upon qx, such that qx cannot be 0. We solve integrand containing rational function with the help of a method called as partial fraction. So let's move and we'll learn how to solve the rational function, how to solve the integration containing rational function by partial fraction. A rational function can be of two types. First type I am writing and type 2. Px upon qx. In this case, I can take degree of px is smaller than degree of qx. And in second type, degree of px is greater than or equal to px greater than equal to degree of qx. So basically these two types of rational function we can get to solve. So whenever we'll get first type of rational function, we call this rational function as proper rational function. It is called as proper rational function. And second type of rational function is called as improper rational function. So whenever we will have improper rational function, that is degree of px will be greater than degree of qx, we'll try to convert improper into proper. Then we'll proceed with the method of how to solve proper rational function. Now let's consider we have a improper rational function, that is px upon qx. Here degree of px is greater than equal to degree of qx. We are watching how we can convert improper function into proper rational function. So what we'll do, since degree of px is greater, so obviously we can divide by qx to px, and we'll get something like qx plus rx, where rx is remainder upon qx. So now the degree of rx will be smaller than degree of qx. Again here we can see this portion has become proper rational function. Since the degree of rx is smaller than, that is the degree of numerator function polynomial is smaller than the degree of denominator polynomial. So this is the way we convert improper rational function into proper rational function. So whenever we will have improper, we can convert into proper. Now we'll learn how to solve proper rational function, how to solve integrand containing proper rational function. So now considered, actually there are certain form through which we solve such integrands. So I'm writing here form, and I will keep on explaining those things, those types. So at left side I'm writing such forms, and in right side I will write partial fractions. Okay, form of px upon qx such that I'm taking here as improper rational function. Okay, degree of Px is smaller than degree of Qx. This side I'm writing partial fraction. And here I'm considering that certain thing Li as linear expression. Linear expression means an expression with degree 1, and Qi as quadratic expression. That is expression with degree 2. And we can note down this Qi is, we cannot convert Qi into linear form. Those Qi we are considering here. I'm writing here which can't be converted into linear form. Okay. I'm giving you example, like if you have a quadratic expression like x square plus 2x plus 1. So we can convert this quadratic equation in the form of x plus 1 ka whole square. Basically it can be converted into x plus 1 into x plus 1. So here I'm able to write this quadratic expression in the form of two linear expression. So we are not considering such quadratic equation. Qi is those quadratic equation, we cannot convert them into the form of linear. Like we can write x square plus 3x plus 1. Now we'll not have any proper such thing. If like, can we convert it? So we'll have discriminant equal to b square minus 4ac. So it will be root 5. So probably we will not be able to convert this. So now I'm moving. So type 1 is Px upon L1 into L2. As earlier I told you, Px and Qx are polynomial. It can be of any degree. Just I'm mentioning it is polynomial. Okay. So Px upon L1 into L2, where L1 is linear expression and L2 is another linear expression. So if we'll get integrand in the form of this, we cannot solve such integration. It becomes very hard. So what we can do, we can convert, we can solve this by partial fraction. So the partial fraction of Px upon L1 into L2, what we can write? We can write A upon L1 plus L2, B upon L2. Main thing is that that you can get this expression anywhere, in NCERT also, in RD Sarma, everywhere it is there. But we need to understand why we are writing Px upon L1 into L2 in the form of A upon L1 plus B upon L2. See here, the reason is that once it is very simpler, this form is very simpler to like we can integrate it very simply, because A is some constant, we can throw it outside, B is also some constant, we can separate them into two integration. Like if it is whole integration, I can write in the form of A upon L1 plus integration B upon L2. And now since it is linear, it is also linear, so we can directly write log L1 plus log L2. But problem is that why we are writing Px upon L1 into this form? See, it is like heat and trial. We can guess it. What will be LCM of A upon L1 plus B upon L2? LCM will be obviously L1 into L2, and we needed also LCM in denominator as L1 into L2, because here it is Px upon L1 into L2. So again I have L1 into L2 and A into L2 I will get plus B into L1. Since L2 is also linear, L1 is also linear, in numerator also I will have some linear expression. and here also this side. Okay, wait, this is some, there is no need of it. So here we had px upon L1 into L2. So here in numerator we have some polynomial, and here also we have some polynomial in numerator. Main thing is that degree of px, here degree of px cannot be greater than, greater than 2, or even cannot be equal to 2. Degree of px will have to be smaller than equal to 1. So obviously the degree of px is here is more than equal to 1, and here also L2 and L1 is linear. So degree of here in numerator I will get maximum L1. So we can compare numerator, and we can get the coefficient of the value of a and b by comparing both sides. So it is very good that we can assume, we can break this form into a upon L1 plus b upon L2. I hope you understand it. So I am writing px upon L1 L2 as a upon L1 plus b upon L2. So we can solve such integrand by breaking them into this partial fraction, a upon L1 plus b upon L2. Now we are moving for second expression, second such form of px upon qx. Now we have px upon L1 into L2 into L3. Here the degree of px can be maximum 2. It cannot be greater than 2. So accordingly we can guess its partial fraction. As in the previous form we have broken them into a upon L1 plus b upon L2. So here I can break them into a upon L1 plus b upon L2 plus c upon L3. See, here it is very easy to understand, or you can mug it up, like because in previous case we have broken into 2, so here we can break them into 3. Main thing is that now you need to understand why we are breaking them into. See, here I need in denominator 3 degree of polynomial should be 3. So once I will take LCM, these all polynomials are different, so obviously it will give me a degree of 3, L1 into L2 into L3. But once I will write here a into, so I will get here L2 into L3, the degree of L2 into L2 into L3 I will get 2, and here also the degree of px can be smaller than equal to 2. It cannot be greater than 3, not even it cannot be equal to 3. So that is why here also degree of numerator can be maximum 2, because here it will be b into L1 L3 plus c into L1 L2, and here also degree of px can be maximum 2. So now you are understanding why we are breaking them into this form. Okay, so now easily we can compare and we can get the value of a, b, c, and we can write px upon L1 L2 L2 px upon L1 into L2 into L3 as a upon L1 plus b upon L2 plus c upon L3. So we are writing, where px is some polynomial, it can be of any degree. Again I am writing a upon L1 plus b upon L2, where a, b, c are constant. Now we are moving on to third form of rational expression. Third form is of type px upon L1 square L2. Here you can observe one thing, I told you in starting only. See, L1 square is also a quadratic expression. and but it is totally different from qi. Qi cannot be written in the form of two linear expression, but here it is in the form of two linear expression. L1 square means what? L1 square means L1 into L1. That is, it is multiplication of two linear expression. I hope you are understanding why there is difference between Li and Qi. This is the only concept where people are getting confused in partial fraction. Otherwise, partial fraction is quite easier. So what we can do here? If we try to guess it, we'll break them in the form of a upon, obviously it should have been a upon L1 plus b upon L1. If you guess, it should be L1 plus c upon L2, because from previous two cases we can guess something like this, and this is not correct, but obviously if some new people is there, they will try to guess it like this, because it is what? It is px upon L1 into L1 into L2, because in previous case we had broken them into 3. But problem is that if I take here, now let's say, what will be LCM? It will be LCM will be L1 into L2. But here the degree is 3 of polynomial, but here I am getting degree as 2. So I cannot take this partial fraction for this rational function px upon L1 square into L2. So I need to change partial fraction. What I will do? I will start with L1. Okay, we will start with L1. A upon L1 plus, we'll move on to b upon L1 square, because in numerator again the degree of px will be what? Smaller than equal to 2. So degree can be 2 also, but here if I am taking L1 into L2, so my numerator will never be of degree 2, it will always be of degree 1. So that's why I am taking b upon L1 square. Now c upon L2. So this rational fraction can be broken into this type of partial fraction. So we can write px upon L1 square into L2 as a upon L1. If you want to remember it, you can remember it like this. You will start from L1 plus, you will move on to L1 ka square, and you know reason why we are moving. I have explained it here. It is c upon L2. So here I will cover them into boxes. So this is third type of rational function. These all are proper rational function. So now I am moving on to fourth type. Fourth is px upon L1 cube plus L2 square upon L3. I hope you can easily guess it. Again we will start with a upon L1 plus b upon L1 square. We will move on to maximum degree, c upon L1 cube plus d upon L2 e upon L2 square plus f upon L3. And why we are moving on to degree 1 to degree 3? Because I need in numerator also, because here the degree of again px can be smaller than equal to, here degree is 3 to 5, 1, 6. So it can be maximum of 5 degree. So here also need some polynomial of 5 degree. It can be, I don't need exactly 5, but if here it is 5, so here also I need 5, because I am breaking this expression, rational expression into partial fraction, this type of partial fraction. So obviously they will have to be equal. That is why I am writing in such form. I have explained it earlier also. So it is of fourth type. So now I am moving on to fifth type. Fifth is px upon L1 into Q1. Now here we can note it down. The degree of denominator is 3, because one is linear expression and one is quadratic expression. So here we can break it we'll break this rational expression in different way. We'll write px upon a upon, obviously it is linear, so I'll write L1. You need to observe one more thing. I'm writing the degree of L1 is what? It is 1. So whatever we'll write in numerator, I'll write degree of numerator is smaller than the degree of denominator. And it is just 1 smaller. So here degree is 1, so I'm writing here degree as 0. So again, I will break B, I will write obviously. Here it is quadratic expression. But main thing is that since it is quadratic expression, so degree is 2. So what should be degree of on numerator? You can guess it. If degree was 1 was there of denominator, so we wrote degree 0 of numerator. Here degree is 2, so we'll write degree as 1. And why we are doing this again? Because again we have to equalize it. If we will not write, we might miss some term containing x, and then we'll get some wrong answer. That is why we have broken them into such partial fraction. So we'll write px upon L1 into q1 as a upon L1 plus bx plus c upon q1. Now we can move on to sixth form of rational function, rational expression actually. Sixth is px upon L1 square q1 square. So again here degree of denominator is what? Degree to, here already degree of q1 is 2. So again power is 2, so it is 4, and degree of L1 is square, so it will be 6 degree, and degree of px will be, px can be smaller than equal to 5 since it is rational expression I'm taking. Okay. So I'll break them into, now you need to guess it. Obviously we will start with a upon L1 plus b upon L1 square, okay, plus not is again q, we will start with again q1 as we have started with L1, so it will be cx, but q1 is quadratic, so we'll write cx plus d upon q1. Again I'll write q2 square, q1 square, okay, q1 was there, so q1 square I'll write plus d, cx plus d, so I'll write here d ex plus f. So why I'm writing ex plus f only? Since see here L1 square is there, then 2 I'm writing degree 1, just 1 is smaller than a degree of denominator. So here also q1 square is there, so I'll write degree of numerator is just 1 is smaller than degree 2. That's why I've written degree 1. So that is we have here px upon L1 square into q1 square as partial fraction as a upon L1 plus b upon L1 square plus cx upon d, cx plus d upon q1 plus ex plus f upon q1 square. See, there can be many more types of rational function of proper rational function. We can make it. We can take q1 cube, we can take L1 power 5, 6. But I hope you are understanding how to break them into partial fraction. So right now we'll solve one or two questions related to partial fraction. One question will solve integration x plus 2 upon 3x minus 1 plus 4 minus 2x into dx. See, now we cannot use here. Can we use some other method earlier to, like, this is 7.5th exercise in NCERT. So can we use all the other method that we had it till 7.4? We have used inspection. Can we try? We cannot, obviously. Can we try substitution? Can we try transformation? And can we try any other thing? That identity of type 1 by under root x square minus a square? Obviously, we won't be able to apply here. So each integration has its own method that you need to know. It might be that you will try some other transformation and you might be able to convert this integration into some other form, but that will be very rare. That case will be very rare. So you need to know which like how to solve such integration. But main thing is that how will you guess? Yes, what you can do, you can observe that given expression is linear. It's okay. Here this is also linear. This is also linear. It was also linear, and it is also linear. Since all are linear, so I can obviously call this numerator as px some polynomial, and denominator as, again, degree 2 is there, so it is in the form of something like px upon L1 into L2, and degree of px is smaller than degree of denominator. So it is of type proper rational expression. It means that we can apply here the partial fraction of given integrand. So what we'll write here, x plus 2 upon 3x minus 1, 4 minus 2x. I can break them into this form. A upon a is some constant. Linear expression was is 3x minus 1, so I'll write 3x minus 1 separately, plus b upon 4 minus 2x. Here it means that both given LHS expression and RHS expression both are same. Just I want to find some proper constant, what is value of a and b. Then we'll be easily able to integrate by separating them into two integration. And this is the advantage of partial fraction. So I am solving RHS. So once I will take LCM, I will get 3x minus 1, 4 minus 2x. See, both are almost same, means same. Just I want to find a and b by comparing numerator here. So I'll write here a into 4 minus 2x plus b into 3x minus 1. There is no need to cancel denominator and denominator. I don't need. There is no need to do such thing. Just I will compare numerator and denominator. So right now I can write 4a minus 8x plus 3bx minus b, okay, upon 3x minus 1 plus 4 minus 2x. Now further we can simplify it, but I am leaving it. Just now I am comparing both sides. Comparing both sides. Comparing both sides. We are comparing the coefficient of x both sides. So we'll get 1 equal to 1 is from LHS, and from RHS what we will get, minus 8 plus 3b. So this is number 1 equation. Okay. Wait. So a into 4a. Oh, it will be not. It will be 2a. 2a plus 3b. So I'll write here minus 2a. Okay, here it is minus 2a, not 8. So it will be minus 2 into a. So minus 2a plus 3b equal to 1. And now I'll compare the, the constant both sides. Comparing constant both sides. Get constant in RHS we have 4a minus b. 4a minus b is equal to, in LHS we have constant as 2. So I'll write 4a minus b equal to 2. So now I have two equation 1 and equation 2. So now I have to solve equation 1 and 2 by elimination method to get the value of a and b. So we have 4a minus b equal to 4a minus b equal to 2, equation 2 I am writing here. And what we will do, we will multiply here by minus 2. So I'll get 4a minus 6b equal to minus 2, and now I'll subtract them, minus plus plus. So I'll get 6 minus 1, 5b equal to 0. So here I will get 5b equal to 0. So the value of a will be 2 upon 4. So I'm getting 1 upon 2. Okay, let me check it. Minus 2a plus 3b equal to, so it will 4a minus b equal to 2, it's okay. Minus 2 minus 4 plus 4a minus 6b. So 4a minus b equal to 2. So minus minus cancelled, plus okay, 6 minus 5. So this become plus, okay, it will become 4. So b will be 4 upon 5. So now I can get a also. So b is 4 upon 5. So 4a will be equal to 2 plus b, as 4a minus b equal to 2. So what I'll write here? I'll write a equal to 2 plus 4 upon 5 by 4. So I'll get a equal to 10 plus 4, 14 upon 20, 7 upon 10. I will get. Okay. So now we have the value of a and b. So I can put them into our partial fraction. So I'll get x plus 2 upon 3x minus 1 by 4 minus 2x equal to, it was a upon 3x minus 1 plus b upon 4 minus 2x. So I can write here a as 7 upon 10 by 3x minus 1 plus b as, what is b is 4 upon 5. So 4 upon 5 by 4 minus 2x. So so now I have broken given expression in the form of two partial fractions, two expression. So now I'll integrate it. Integration x plus 2 upon 3x minus 1 by 4 minus 2x dx equal to integration 7 upon 10 by 3x minus 1 plus 4 upon 5 by 4 minus 2x dx. So now I can separate them into two integration. So I'll write 7 upon 10 by 1 upon 3x minus 1 dx plus 4 upon 5 integration 1 upon 4 minus 2x dx. So here now we can easily integrate such integration because it is in the form of integration. I will get in the form of log. So I'll write 7 upon 10 into log 3x minus 1, but here 3 is in coefficient with x, so I will have to differentiate it also. So I'll get 3, but since it is integration, so I'll place here at 1 upon 3 plus 4 upon 5 into log 4 minus 2x again, but we'll have to again differentiate minus 2, so I'll get minus 2. I'll write here 1 upon minus 2 in bracket plus c. So I can write them into 7 upon 30 log 3x minus 1 minus 2 upon 10 log 4 minus 2x plus c as our answer. So this was first integration by partial fraction. I hope the value of a and b are right. If it is wrong, there is no problem, but we'll proceed in same fashion for such type of question. So now we are trying second question. Now considered we have integration dx upon x plus a into x plus b into x plus c. Now I need to break a given rational function in the form of some partial fraction. So but it is of type px upon L1 into L2 into L3, if you remember. Here px is what? It is constant polynomial. Degree is 0. So we'll write 1 upon x plus b plus x plus c. So I can write as a upon x plus a. Although this question seems to be quite easier, but it becomes quite hard since everything is in the form of some constant, no value is given specific. So c equal c by x plus c. Again we can take LCM, x plus a into x plus b into x plus c, a into x plus b into x plus c into plus b into, it will be x plus a into x plus c, plus c into, it will be x plus a into x plus b. So now there is no need to solve further, we can directly compare. So I'm directly comparing the coefficient of x square. So the coefficient of x square is in RHS. Here the coefficient of x square in LHS is what? I can write 1 in plus 0 into x square, I can write obviously, plus 0 into x also I can write. So here coefficient of x square is 0. So 0 will be equal to coefficient of x square is x square into xc bxc. So x square coefficient will be a plus x square coefficient will be x square bx square. So it will be plus c. It is equation 1. Now comparing the coefficient of x. So I'll get, it is 0 in LHS, no x. So it will give me cx into bx. So I'll get a into, again let me, it will be x square, a should be in multiplication, so it will give me cx, c plus b plus, here I will get b into, yes, b in multiplication, c plus a plus c in multiplication, b plus a. Okay, A and B, C are some particular value will be given in all remaining question, but here they have not given such value for this question. So I have here again equation implies A into B plus C plus B into C plus A plus C into B plus A equal to 0. This is second equation. Now we will compare the coefficient of constant. So in LHS it is comparing coefficient of constant both side. Will get 1 in LHS, and then in RHS what we will get? It is B into C into A, then BAC, ABC, BCA, CAB. So it is ABC plus BCA plus CAB, something like this. Yes, CB, yes. So now we have three equations. They are A plus B plus C equal to 0. No, capital A. Yes, capital A should be there because they are the one constant. A plus B plus C equal to 0, equation 1. Number 2 equation we have A into B plus C, B C plus A, C B plus A. So we have A into B plus C plus B into C plus A plus C into A plus B. This is equation 2. Now third equation we have, it is ABC BCA equal to 1. A ABC plus BCA plus capital C AB. For a smaller C I am writing like this C here, okay, otherwise it will be confusing. This is equal to 1 by equation 3. Now we have three equations with three variable, and so we can solve this type of system of equation. Either we can apply matrix method to solve matrix method. If you have studied it was there in first part even. It will be A B C equal to 0 0 1, and then matrix we have 1 1 1, B plus C, C plus A plus B, B C, C A and A B. By solving again it will take some more like more 3 to 4 minutes in solving for A B C. By solving we'll get the value of A as 1 upon B minus A, C minus A, and the value of B will get 1 upon A minus B into C minus B, and the value of C will get 1 upon A minus C into B minus C. So now since we have the value of capital A, capital B and capital C, we can directly put them, and then we will get the partial fraction of given expression. So we will have 1 upon x minus A, 1 upon x minus B, 1 upon x minus C as A upon x minus A plus B upon x minus B plus C upon x minus C. Since the integration of this will become integration of dx. So now if we will break into three integration, I'll get integration of, I'll write the value of A outside. So the value of A is what? B minus A into C minus A. Equal to B minus A into C minus A, directly you can write by 1 upon x minus a. Now it is very easy to integrate 1 upon x minus a plus what is value of b? The value of b is 1 by a minus b. 1 by a minus b into c minus b. Integrate 1 upon x minus b dx plus the value of c is 1 upon a minus c into b minus c. Integration 1 upon x minus c dx. So answer will be 1 upon b minus a into c minus a log x minus a plus 1 upon a minus b into c minus b log x minus b plus 1 upon a minus c into b minus c. Into log x minus c plus c some constant will be our answer. So here I have covered two questions today for partial fraction, and in next video I will try to solve all the questions of NCERT of chapter 7.5. So I hope you liked video. If you like this video, you can subscribe our channel for more such videos. So thank you and bye.